of course, if we can take the derivative of, well, really all the sides of this equation up here for the geometric series, that the function's equal to the sum, which is equal to this sum written out, which is equal to this function, then rather than just taking the derivative of all the parts, why don't I integrate all of the parts? So I have it all written out again, but you'll notice I left some space because I want to take the integral of every piece of this. So I'm going to integrate f of x, which means I'm going to integrate this sum, which means I'm going to integrate this whole piece, which means I'm going to integrate this piece, right? Because they're all equal to each other. I'm working in tandem. I'm doing the sum, which means I'm doing this piece, which means I'm doing this function. And I'm going to create a new function out of this, right? So the integral of f of x will be, well, capital F of x, right? No big deal. And then we'll just kind of skip over that because we're going to figure out what this is in summation notation as we do it. All right, so let's do this middle piece. What's the integral of every one of these? So integrate each one of these with respect to x. That'll be this portion that we're going to build down here. All right, so if I integrate 1, that would be x plus, and then I integrate x, so I add 1 to the power, that would be x squared divided by 2, plus x cubed divided by 3, plus x to the 4th divided by 4, and then you continue in that vein. This would be x to the k plus 1 over k plus 1. And we would continue. And then there will be a plus c at the end of this, right? Because we're integrating and it's an indefinite integral. There will be a constant added in. We'll figure that out in a little bit. And that would be equal to, well, the integral of 1 over 1 minus x. Well, let's see here. I think that's going to be, it's a little bit of u substitution. U is 1 minus x. Du is negative 1 dx. So I would have negative, the integral of 1 over is natural log. So, oops, there's no more integral sign though. I'm doing the integral. I wasn't sure I was going to when I first started writing, but I realized I can do this. So this is negative natural log of the absolute value of u, which is 1 minus x. Right? You could think of it as having a plus c on both sides, but it doesn't really matter because it's a constant, so you can just kind of put it wherever. It's fine. And then this will only be true for the interval of convergence. Geez. So let me just say I'll just write it up here, for the absolute value of x is less than 1. Okay, so I did a little integration here, just real quick. And then I did integration of each piece of this. All right, but this is no good. We don't want to write it like this. I want to write it in a summation notation. So I need some way to represent what I'm looking at here. So let's let this be my 0 term, this be my first term, this be my second term, and so on. And I'm having a pattern going on here. And I need to be able to write that pattern. Okay, well, what is it? So let's see, it's a summation. It's starting at 0, it's going to infinity. There's obviously a fraction going on because I can see all the 2 and the 3 and the 4. And actually that denominator part's pretty easy to do, right? And it's sort of, you can see it right here, right? Because this is the kth term, right? Or the k plus 1th, right? It's the kth. So this will be the kth term because 4 goes to 3, k plus 1 will go to k. So you can see it's going to be k plus 1, x to the k plus 1. Nice. Convenient, don't you think? Okay. And so then it's plus a c, right? So we got to figure out that c bit, which we'll figure out in a second. And this will be equal to the negative natural log of the absolute value of 1 minus x. All right, so let's go find c really quickly. right? To solve for c, use the center, which is x equals 0, right? Okay, so if you plugged in x equals 0 into this, what would happen? You would have the negative natural log of 1 minus 0 equal to, I kind of wrote them backwards. I'm reversing it because I'm doing the easy part first, which is over here. And then it's going to be, if you sum this, every term will be 0. So it's 0 plus 0 plus 0 plus 0. So it's a sum of zeros plus c. But the negative natural log of 1 is negative 0. So this is 0, and that's c. So 0 is c. So therefore, I don't need this. Right? From the x to the k plus 1 over k plus 1, we don't need to write plus c. That's a k right there. Right? So we don't need to write it. We can just drop it because it was 0. It might not always be 0. This one just worked out to be 0. All right, lovely. And notice, by the way, 0 is the center because look at your interval, right? Your interval is from negative 1 is less than x, which is less than 1. It's the interval of convergence. So that'll work, right? That's 0 is the center of that, and that's where that came from. All right, now I love to give this a big old box and just say, we're done, yay, right? I would like to have my interval of convergence and be all finished. And I have the beginnings of it, but I need to check it. So the interval of convergence is from negative 1 to 1. Convergence. Sorry, my V got weird there. All right, my interval of convergence is negative 1 is less than x, which is less than 1, but I have to check endpoints. Because you never know, one of them might work out. Okay, so what are the two endpoints? I have x equals negative 1. If I have x equals negative 1, then my series is negative 1 to the k plus 1 over k plus 1. Right? That's an alternating harmonic series. That converges. I mean, granted, it's got plus 1 in it, but that doesn't change the fact of what it is. Right? This is alternating harmonic series. This converges. We actually have to include negative 1. Right? And then let's check x equals 1. Hey, it works so well for x equals negative 1. Let's see what goes on. So 1 to the k plus 1 over k plus 1, that's harmonic. Diverges. Right. So there we go. So our interval is negative 1 is less than or equal to x, which is less than 1. There's our interval. Because it converged for negative 1, but diverged for positive 1. And we've now created a new power series for a new function, negative natural log of 1 over minus x. Which, by the way, you don't have to have the negative over here. You can make it positive natural log and just put the negative out in front. That would also work.